All right, good evening from Bloomington. This is first week's Business for Business Econometrics Zoom live session recording. So I'm going to talk about a brief introduction to our course, Business Econometrics, and we will have a brief overview of statistics, and we'll continue with that next week as well. So let me start with telling who I am. My name is Kerem Chakrar. Kerem is like saying Karen, but with M, Kerem. Chakrar, there's this chi sound, right? It is basically chocolate, che sound. So you have Chucky and Rare. If you say this together, my name is like Chakrar. So that's perfect. You can call me Professor Chakrar. You can call me Kerem. You can call me Mr. C if you would like to, like the Warrior, the movie, right? But please show some respect, and I really appreciate the respect. I'll show you the respect as well. And I'm a friendly guy, but don't call me dude because I'm still the professor, right? So here's a brief background of where I am. I'm from Istanbul, Turkey, and I studied math in Bilkent University, Ankara. But I decided to apply math into more real life situations, so economics. So I studied my master's and PhD degree in economics at Texas University, UT Austin. And I have been teaching in Cali for 12 years. I have been teaching business econometrics, game theory, and managerial economics in Cali School of Business. And I'm so happy to do it. Now, this course is business econometrics, but what is it about, right? So we will have lecture slides, practice problems, practice tests, and data for you to work with. Lectures are slides, and I would like you to weave them in slideshow. And then we have the Zoom sessions every Tuesday starting at 7. We will meet and we are going to discuss the week's highlight. And I will be working with data time to time, but I am expecting you to work with the data using Excel. So your kind of a support will be provided. You can check the course overview. So every week there is a new topic, and there will be a live session almost every week. There are 4 assignments, and we have the midterm exam and the final exam. So what's our goal? Our goal is making you feel comfortable estimating, interpreting, critiquing, and justifying the econometric models. So you're going to come up with models, functional forms, and try to estimate it. But in the bigger picture, you will be able to extract information from data sets. So you have all these numbers, right? What are all these numbers really mean, kind of? And you're going to properly address the challenges to your econometric analysis if and when they arise. So we have 4 team assignments, so make sure you know what team you are in. And we have tests, which will be multiple choice and short answer, but it will be coming from the materials from the slides, the problem sets, and the topics we have been discussing. So what's econometrics, right? The main goal of econometrics is to predict the future, how you see the data, which is the past, and then transform the data into the next thing, the future. Of course, it's almost impossible to know the future. Nothing is 100%. So we will try to get close to 100%, like 97.5%, which is the idea of the confidence intervals. So we're going to understand the outcome of what we call as the random variables, such as which school will win the NCAA this year, right? Or NBA, or how many iPhone will Apple sell after the launch of new generation iPhones. These are the things we can predict. And if we use the data in the most efficient way, we can predict in a more robust way. Econometrics will help us to understand the data on 2 more variables. And then we're going to use the data to come up with a model when we are making a decision, such as, right, your credit score. The credit score depends on many data you are collecting, but what the companies are trying to see is trying to predict the probability if default using borrower's characteristics. So it's an econometric model. And then they're going to make a decision, right, whether to lend or not. So in the real world, there are a lot of things econometrics can help. For example, TV ratings, how valuable the ad slots are. Like for example, the Super Bowl, right? It's way more expensive than 8 a.m. in the morning in a very normal day. Why and how? econometrics can help us to understand the value of it. And in business, there's a huge kind of application of econometrics. Netflix is one of the, the biggest companies, uses data work a lot, coming up with their own shows and then the own productions to create value and then understand what to do with that value, such as increasing the price by $2 and no one drops Netflix because it's pretty inelastic, and they understand how the demand is inelastic or elastic using econometrics. So what's econometrics then? Econometrics is coming up with a functional form to understand the outcome, such as how many cars will be sold given the price of cars and the other stuff, right? So we're gonna collect data on the parameters and try to determine what the function is gonna look like, right? If we are interested in the computer sales, we're gonna collect data on computer sales and then try to determine what the functional form of the sales are gonna be using the theory in a way. And to do this, we are gonna estimate the parameters of alpha and beta given the functional form is alpha plus beta times price. So in a way, we will be following a linear kind of functional forms. And you find econometrics in life as well, such as the book Freakonomics. I strongly recommend you to read the book. But let's start with the understanding the random variables. What's a random variable? Random variable is a kind of a description of an event that can be true or false in one from another, such as a city in US being struck with flood. This is event X, and event Y is an occurrence of an earthquake in California, which flows the city of Los Angeles. Which one is more likely? Now, in terms of more specific items, could be less likely, but it is not, right? One is the subset of another. In fact, event X is more likely than event Y because Y is a subset of X. So we are going to create probability spaces, and depending on the probability spaces, we're going to find the probability of what the really random variable can be, right? Because we are going to predict what that really random variable is going to be. So what's a random variable? It is a variable that takes different values as from trial to trial in an experiment, such as NBA game. How many points will there be? It is going to change, right? But it's going to change from a range, and we will try to understand what that range is going to be. So we have discrete random variables and continuous random variables. We will be working with continuous random variables most of the time. And these random variables will be characterized with a probability distribution function. And the most common one is the normal distribution. Normal distribution is characterized as the bell curve and distributed normal with mean mu and variance sigma squared. And can take any real number. And we're going to characterize with the random variable X with the distribution, the normal distribution, mu mean, and sigma square variance. There are some characteristics of it which really works fine with our analysis. It's bell-shaped and symmetric, and it's asymptotic distribution. And it is the most common continuous distribution. And this is what we see in the nature. The expected value will be the mean, and there is a way to calculate the expected value. And the variance is called as the Vx, and it is basically the expected value of the random variable x squared minus the expected value of x squared. And we can calculate the variance given the random variable values and the expected values. We'll have some examples next week, even more, when we are discussing the random variables in a more detailed way within the statistics overviews. But we need standard deviation as well. By definition, it's the square root of the variance. So why is this useful? Because this is the common distribution in the nature you see. And in fact, we're going to transform any normal distribution into a zero mean, one variance normal distribution, which we call as Z as the standard normal. And it looks like this, a bell curve, right? It's going to be a bell curve. So we're going to transform any random variable with a normal distribution to a standard normal, because transforming it is not going to change the distribution at all. It's going to change only the shape of the distribution. So this is a basic kind of the proof this slide is the basic proof of why expected value is 0 and the variance is 1. So please study why we are basically claiming the transformation will not change the distribution. But why are we making this transformation? Because any random variable can be transformed easily to a standard normal. And when we are trying to understand the probability distributions and probabilities, we need to only read the standard normal, not any table for the normal distributions, because there are infinite number of tables of normal distributions. So this is the recording of week number 1. Next week, we're going to discuss statistics with examples in more detail. And hopefully, I will see you next Tuesday and we will be discussing more. Until then, take care and enjoy the weekend. Bye-bye.